This is Selena and Samantha, and we're doing MCV Unit 11 bonus video. This is page 570, number 17. The cross-section of a water trough is an equilateral triangle with a horizontal top edge. If the trough is 5 meters long and 25 centimeters deep, and the water is flowing in at a rate of 0.25 meters cubed per minute, how fast is the water level rising when the water is 10 centimeters deep at the deepest point?
So to solve this, we will use the grass method, and our first point would be the given. So we have a diagram here that outlines what the trough looks like. So we have the 5 meters long and 25 centimeters tall, which is also equivalent to 0.25 meters. What we're given here, dV over dt, is 0.25 meters cubed per minute, and we have to solve for, which is our required, the dH over dt in terms of time when h equals 10 centimeters or 0.1 meters.
So to start off our formulas, the formula, we have to look at the equation of a triangle. The area of a triangle we know is a half times base over height, but we need to know the specific measurements. According to the similar triangles, we know that the 25 centimeters is the height, which is equivalent to the square root of 3 part in the similar triangle. And in order to get the other two sides, which is the 1 and the 2, we have to figure out what that is in this triangle. So if that top part is 1, the side part is 2, and this left part is square root 3. We know that in order to get from 1 to square root 3, we have to multiply 1 by square root 3. Since 25 centimeters is the square root 3, in order to get back to 1, we divide by square root 3. That is how we get 25 over square root 3. The same goes for the 50 over square root 3. To get from 2 to square root 3, we have to divide by 2 and multiply by square root 3. Since 25 centimeters is square root 3, in order to get back to the initial value of 2, we have to take 25 centimeters times 2 and then divide by square root 3. Therefore, we get our formula R equals h over square root 3 in respect to this unit. So we know our area is half base times height, and we know that the base is 2r. The 2.5 cancels out, so it becomes RH. And we know r is equal to h over square root 3 times h is h squared over square root 3. Plug that into our formula for volume. Since it's times length, we multiply by 5 meters. And that gives us our formula for volume.
So what we now have to do is to differentiate both sides of the equation. So you have v from before, so differentiating v is dv over dt, and differentiating the al, which is also the 5h square over square root of 3. So in order to differentiate that, you have to multiply by dh over dt. And you go through the Unit 10 differentiation rules and drop the 2, multiply, that gets you there, and then you isolate this, remove the h, so separate the h so you can fit an h, because you are given h from before. From up here, you are given 10 centimeters or 0.1 meters, and you want to keep it consistent, so you're going to put it in 0.1 meters. You're going to multiply that again, and that gives you 1 over square root 3 dh over dt, and you divide 0.25 meters cubed per minute divided by 1 over square root 3, which gives you dh over dt is equal to square root 3 over 4. So that means in our statement, we're going to write the water level is rising at a rate of square root 3 over 4 meters per minute.
Thank you for watching.
Woo!
Good luck on your tests.